Hello friends, this video is a short introduction of corporate IoT training by Hytron. The complete training is 60 hours which include 5 modules. Each module is divided into several sessions. Usually every session is of around 3 hours. So let me walk you through training content and the projects which will be the part of this training. So the module number one, this module includes 4 sessions, which will be around 12 hours. And in the first session, we will learn about IoT end-to-end explanation, what the IoT is, and how end-to-end product has been built, IoT architecture, and 3 level of communication. So in the first 3 hours, we will learn about the different segments, different level of communications that involves while building IoT product or IoT applications. It includes device to device communications, device to server communication, and server to server communication. In the session 2, we will spend another 3 hours to learn about hardware designs. We will learn about different open source devices, like some of the hardwares, like say for example Arduino and Raspberry Pi, BeagleBone, and El Galileo, and we will discuss all of them, and we will see how they are different from each other and how they fit into the requirements. So we would also learn about the selection criteria, how we can decide that which open source device fits very well for our requirements. And apart from that, we will learn how we can interface the sensor so that we can talk to the external physical world. We take the data from the sensor and read it into the platform, different interfaces that we have. In the next session, that will be the session 3. We will spend another 3 hours to learn about communication theory, where we will talk extensively about OSI model. OSI model has a different layers and protocols that involve. So we would talk about each of them, and we would also discuss about their roles into the IoT architecture. I mean, how they place their roles. There's one important thing about the IoT. The reason why we learn about the protocols is each and every protocol has its pros and cons, and also we will not only compare them, not only learn about them, but we would also in and all together we will learn about their response times. I mean, how at each and every level of communications in the OSI model, what would be the response time. And we would also do some networking overview, and we will talk about the networking layers and how they works, how they play the part into the IoT applications. The next session will be the session number 4, where we would spend another 3 hours to learn about connectivity and the most messaging protocols. We would also learn about communication channels and IoT cloud platform. Uh, to be if you want to get details about this session number 4, then we will learn about different types of messaging protocols. So I just give you a couple of examples. You might be knowing some of the HTTP protocol, hypertext transfer protocol, then SMTP, simple mail transfer protocol, and MQTT, message queue telemetry transfer protocol. And just all sorts of messaging protocol we will learn, and we will compare them, how they are different from each other, and what sort of advantages they bring when we use them into our IoT applications and product development. We would also take them as a protocol and talk to the IoT cloud platform. So we would use these protocols to send the messages back and forth to the IoT cloud platform. The module number 2 is also consists of 6 sessions, which will take around 18 hours. And this session is this module is very extensively about the practical sessions, where we get our hands dirty with Arduino, and we would learn how we can build the applications using Arduino, IoT applications using Arduino, and we will learn about connectivity and messaging protocols. We would also learn about communication channels, that how we can use all those protocols that we have learned in the module number 1, and that can be used to talk to the cloud. So that will be there. So let me split each and every session and tell you that what will be there. So session number 5 will be the next one, where we spend 3 hours, where we will learn how we can how we can use a messaging protocol, HTTP, hypertext transfer protocol. In this example or demonstration, we will be using Arduino with the Ethernet shell. So our communication channel will be Ethernet, and we will be talking to the ThinkSpeak cloud platform using HTTP messaging protocol. So in this 3 hours, we will learn to interface LM35 temperature sensor to Arduino, and using Ethernet that we will be taking the data from the LM35 temperature sensor and send the temperature data onto the ThinkSpeak cloud. So we can not only send the data on the cloud, but we will plot the data uh, onto the ThinkSpeak cloud, and if we want, then we can even further analyze the data or log the data into the ThinkSpeak cloud. And next 3 hours, that would be the session number 6, where we would learn about how we can use SMTP messaging protocol. That is a simple mail transfer protocol where we will use communication channel, which will be the Wi-Fi, and we would going to talk or establish the communication between Arduino and the thing Blink server. So this will be very interesting project where we will create a small little mobile applications using the Blink IoT platform. So we will build a small little application which would have a couple of buttons onto the mobile phones, and as we click the button onto the Blink applications on our mobile phones, we will turn LED on and off, which is connected to Arduino at the other end. So this would be a really cool example which will demonstrate the capability of communication channel Wi-Fi communication using SMTP protocol. The session 7 is a pretty extensive where we will be, spending around 12 hours, which where we would learn a lot about the Ethernet and Wi-Fi communication channels, and we will be using messaging protocols like MQTT and HTTP protocols. And for this, we will be using Hitron's IoT platform, which can be used to demonstrate uh, connectivity protocols like Zigbee and Sub1 protocol. So this will be quite a bit interesting. 18 hours and a lot of lab. The next module is module number 3, where we would be spending 2 sessions, which include 6 hours. So this will be like getting started for into the Raspberry Pi. Raspberry Pi is a single board computer, which is quite a bit advanced microprocessor kit. And in the session number 8, we would learn about IoT hardware description. That means all details about Raspberry Pi and their different models that's been released over several years. We would learn how we can use Raspberry Pi and interface to the different electronic components, like something like connecting LED and switches, and also temperature sensors and other sensors. Along with that, we would start learning about the Raspberry Pi from the scratch. We would not just directly jumping start and writing the codes, but we will be starting from creating the SD card. I mean, from booting Raspbian operating system onto SD card, onto the Raspberry Pi. Then we will learn how we can set up the Wi-Fi on Raspberry Pi. We would learn how we can access the Pi over SSH client. We would learn about Raspbian OS, how it can be done into the micro SD card. We would start from very basic. We would start from almost from using very basic commands for the Raspbian to writing the codes for the Python codes. Session 9 will be in session 9 we will spend another 3 hours where we would learn a lot about how we can use the Python programming languages, and how we can write the small little programs, from small little hello world program to the program which will do arithmetic conditions, loop statements and functions, how to write the functions and loops and all using Python. We would use the same logic which we have used to write the Python. So we will use the Python program to write the code for interfacing analog and digital sensor to the Raspberry Pi. So the next step in the next demonstration that we will be doing is we will be interfacing digital and analog sensors to with the GPIO pins of Raspberry Pi, so that we can use to get the data from the outside world to the inside the Raspberry Pi. So module 4, the next one is a module 4 where we would be having the 4 sessions, which will be around 12 hours. And this will be like a case study of two very famous IoT cloud platforms like AWS and Amazon AWS and IBM Bluemix. The session number 10 into the module 4, which is around 6 hours, where we will learn how we can, use the same Raspberry Pi, which we have learned a lot in the module number 3. So we will learn how we can communicate Raspberry Pi to Amazon AWS IoT platform. We will be using messaging protocol, which will be MQTT and HTTP. The communication channel will be the Wi-Fi because the Raspberry Pi has the Wi-Fi functionality. We can also learn about connectivity protocols like a Zigbee, and so we will put together with the Raspberry Pi and we will talk to the AWS cloud platform. Basically, in this project demonstration of session number 10, where we will be using AWS cloud platform, we will be sending data from the Raspberry Pi to the AWS cloud platform, and we will be establishing communications, and also we will be creating some advanced notification systems where whenever we get the data on the cloud or something happens, then we get the email or SMS notifications. So this will be a kind of advanced part of using AWS cloud platform. Now the session number 11, which will be again 6 hours, where we will be, using the same Raspberry Pi and, establish the communication between the IBM Bluemix. Um, it's it's a very famous IoT platform compared to other um, IoT cloud platforms. So again, in this in this demo, we will be using Raspberry Pi, and there would be, the CAN protocol, that connectivity protocol we will be using is a CAN bus, and we will interface the CAN module to the Raspberry Pi and get the data onto the IBM cloud. So we can log the data onto the IBM cloud, and we can read the data coming from the CAN bus. A protocol. This will be a connectivity protocol will be wired CAN bus, and the messaging protocol will be MQTT and HTTP, and the communication channel will be the Wi-Fi or Ethernet. So the module number 5 is the last one, where we would be having the 4 sessions, and it will be extensive 12 hours. This module number 5 includes the hands-on lab sessions or the demo, where we will not only just building the backend server implementation, but also we will be creating the front-end client solution for the backend. So this will be pretty massive, and this will opens up the understanding of entire end-to-end. This will allow explore the understanding of how the end-to-end product development happens using IoT. So the session 12 includes the hands-on with the Hive MQ broker, which is one of the MQTT broker. We will learn about Apache Web Server. We will do some labs and practical demonstration, where we'll be using MQTT Lens and MQTT FX sort of applications to demonstrate the MQTT protocols, or to learn more about how MQTT broker works in the background. We would also do some virtual client-to-client communications, which would help to understand a better way how the MQTT broker and the server implementations happens, and how they communicate to each other. The next one is a session number 13, where we will be learning about the Mean stack. We would be learning different technologies. Mean stacks include it's a combination of different technologies, and in session number 13 we will be learning about from the installation of Node.js, MongoDB, Express JS, Socket IO, and AngularJS. So we would not only install this different technologies, Node.js, MongoDB, Express, and AngularJS, but also we will be using them to from installations to writing a script, it includes everything. It includes using the Node.js, writing some files, building some small little servers, then get the response from the servers and log the data into the text file. Also, we will be learning about how we can use the Angular JS and the REST APIs. So this all sorts of things will be together into the session number 13. So we will do almost everything in this session 13. We will be creating a server. We will be, logging data into the MongoDB database and many things. Session number 14 is the one where we will be spending a lot of time about um, working with the MongoDB database, and we will be, building the hybrid app using some front end framework, something like Ionic. And so we will be creating the front end client, and we will be talking to the MongoDB so that we can, use the front end client and log the data onto the database, and sorts of small little projects and applications will be learned and built in the session number 14. Apart from that, we would also learn how we can create the analytic model for the existing application that we have built using the hybrid app and MongoDB database. The last one is session number 15, where we would learn like end-to-end IoT model using Raspberry Pi as a gateway, and the Arduino that we have used in the earlier modules. Arduino will be working as a sub gateway, and Raspberry Pi will be the central gateway, and it will be Arduino is connected to the sensor, and then Arduino will take the data from the sensor, and then it will be connected. Arduino will be connected to the Raspberry Pi, which will be our gateway, and take the data and send it to the cloud platform, something like IBM Bluemix. And this is how you can uh, take all the pieces that we have learned in the previous module 1, 2, 3, 4, even 5, and put together and build the entire project around all the IoT technologies. So this is all about 5 modules which we used in our training model. So if you have any question, then feel free to give us a call, or please feel free to write us an email. We will do our best to help you to become IoT professionals. So you can follow us on YouTube, Facebook, and other social media pages. Thank you very much for watching this video, and I hope you will like it.